To chapter 11 of Anatomy and Physiology, where we're going on to now the muscular system. In this chapter, we're really just looking at the muscular system macroscopically. Remember in chapter 10, we looked at it microscopically, looking at the cells, mainly the skeletal muscle cells, and a little bit on cardiac and smooth. Well, now we're going into the macroscopic. Now we're going to look at skeletal muscles, the organs. Remember, these are skeletal muscles because they are attached to your skeleton. That's why they're called skeletal muscle. And remember, it's made up of skeletal muscle tissue, which is what you control. So this is the muscles, or these are the muscles that you're using to move, and you control them. And they're helping you to move basically because they're pulling on your bones. And in order for muscles to pull on your bones, well, they need to attach to them. Oh, and you know the answer, like usual, you know the answer, way back from tissues. Remember, there is connective tissue that attaches muscle to bone. Remember, that connective tissue structure that attaches muscle to bone is a tendon. Make sure you know what a tendon does. A tendon attaches muscle to bone. And now you know really how everything works. You got to put it all together now. You know your skeletal muscles contract. They shorten. And when they shorten, they're going to pull on the tendon, and that tendon will pull on the bone, and you would see that as a movement. So that's how you're moving. And so when we look at all these skeletal muscles in this chapter, we're going to see them attached to bone. And a lot of them attached to bone in more than one place. They have more than one attachment, and in some cases, those attachments are to more than one bone. And you know this is anatomy, so we're going to name everything. We even name where muscles attach. We give two names right off the bat. There's something called the origin and the insertion. They're both bony attachments of muscle, but what's the difference? What's the difference between the origin and the insertion? Well, when you think about muscles attaching to bone, usually there's a bone that's not going to move. It's going to hold everything in place. And when the muscle contracts, there will be a different bone that moves. These attachments are related to the origin and insertion. The origin is the muscle's attachment to the bone that does not move. The stationary bone is the bone that does not move. While the insertion is the muscle's attachment to the bone that does move, the movable bone. And you see in this picture here is an example showing your biceps muscle in the front and the triceps muscle in the back of the arm. Let's look at the biceps, the muscle in the front of the arm. Turns out it attaches to two bones. It attaches to the scapula higher up in the arm, and lower down it attaches to the radius bone. And so you could kind of think which one of these is the origin and which one's the insertion. Kind of think of working out your biceps. You know, when you work out your biceps, one way to do it is with a bicep curl. Lift up a dumbbell and raise it and drop it. Those are bicep curls. Well, think of what moves and doesn't move when you do the bicep curl. When you're working out your biceps in the gym, are you wiggling your shoulder to try to move the scapula? No. The bone that's moving is the bone in your forearm, the radius bone. So when you contract the biceps, the radius bone is going to move. So the radius bone is the insertion point. It's the movable bone. While your scapula, when you're moving the biceps or contracting the biceps, does not move. So the scapula is the origin. The scapula is the stationary bone. So a lot of muscles will have an origin, an attachment to a bone that does not move, and an insertion, an attachment to the bone that does move. And that bone that does move is kind of acting like a lever system. Your muscles kind of act like a pulley system or a lever system, like I mentioned. They're going to pull on the bones to help you to move. And when you move, you could move to lift something up. So kind of imagine having a big rock and taking a rope and tying the rope around the rock and then throwing the rope over a branch of a tree. That will make it a little bit easier to raise that rock when you're pulling it on the rope wrapped around the tree branch. That's kind of how your muscles work. They're pulling on your bones, which is representing the rock, and the tendons are like the rope helping to pull. It's a pulley system, a lever system. And again, these are just showing different types of pulley systems your muscles could do. Like usual, stick to the exam review. So we're going to look at a lot of muscles in this chapter. And like usual, muscles, just like things like bones, will have lots of defining characteristics. There are some unique features to a lot of your muscles. And one of these features is how the muscle cells are arranged. Remember, a fascicle is just a collection of muscle cells. And you remember, a fiber is just a synonym for muscle cell. So when we look at muscles, we can see how these fascicles, how these collections of muscle cells are arranged. And sometimes that will be represented in the name of the muscle. And we name these fascicle arrangements. You do not need to know these fascicle arrangement names for your exam. But like usual, I told you in anatomy, we name everything. For example, if all the cells in your fascicle are running in the same direction, aka running parallel to each other, well, we'll say this fascicle has a parallel arrangement. Or another example is if the cells kind of wrap around in a concentric circle. If they form a circle, well, we're going to say that fascicle has a circular arrangement. So when we look at muscles, we'll see the fascicles. You'll literally see the cells running in a particular direction when we look at the muscle. But again, we're going to focus on the major muscles overall. And again, they're acting like pulley systems. And it turns out a lot of your muscles can actually either help each other out or act against each other. And again, this is anatomy, so we're going to name everything. We give names to the different roles muscles can play when it comes to certain actions you want to do. There are certain names that you need to know the definition for. There's something called the agonist, or sometimes called the primary mover or prime mover. There's something called the agonist, something called the synergist, and if you're reading another textbook, they'll even name something called a fixator, Fixator. So what are these roles that these muscles could play? What are these definitions for these terms? For example, there's something called the agonist. When your muscle's an agonist, it means that it's doing the desired action. An agonist is a muscle that does the desired action. So for example, I might want to flex at my elbow. And to flex at my elbow is the job of my biceps. So when I want to flex at the elbow, my biceps is the agonist because it's doing my desired action. My biceps is helping me to flex at the elbow, which is what I want to do. So again, an agonist or a prime mover or primary mover does the desired action. And if there's a muscle that could do the desired action, well, there's possibly a muscle that could do the opposite of the desired action. That's what we call the antagonist. The antagonist does the opposite of the desired action. So again, let's take that example of me wanting to flex at my elbow. Well, again, you know the biceps will help me to flex at the elbow, so it's the agonist. Well, what's the opposite of flexing at the elbow? It's extending. And so there must be a muscle that helps me to extend at the elbow, and there is. It's the muscle in the back of your arm. It's called the triceps brachii. Your triceps allows you to extend at the elbow. And so if I'm trying to flex at the elbow, my triceps, it will do the opposite in that case. My triceps are the antagonist. So again, the antagonist does the opposite of the desired action. Keep going. There are more roles to play for muscles. Another role is something called the synergist. The synergist kind of gives you a hint in the name. Synergist for synergy, meaning working together. Turns out the synergist will help the agonist by removing unnecessary movements. That's the role of the synergist. It helps the agonist by removing unnecessary movements. And yet again, I'm using that using the elbow flexion example again. So if I want to flex at the elbow, all I want to do is flex at the elbow. I don't want to do any other unnecessary movements. When I'm trying to flex at my elbow, I don't want my forearm flying laterally or medially. I only want it to flex, not extend, not any other movement. And so to help my biceps do that, I have another muscle involved that will help to reduce unnecessary movements as I am flexing in the elbow. And that will be the job of the synergist. Again, the synergist helps the agonist by removing unnecessary movements. And there's one more role that some muscles could play. It's something called the fixator, F-I-X-A-T-O-R, the fixator. Again, it kind of gives you a hint in the name. It's called the fixator because it's fixing something, meaning it's holding something in place. Turns out, just like in real life, if I tried to move a heavy rock, and if I wasn't careful, if that rock were to slip and begin to roll as I'm holding on to the rope attached to it, I will get dragged with the rock also. Heavy loads could drag the person or thing trying to hold the load. So sometimes you need to be held in place. Your muscles are the same. Sometimes when you're trying to lift a heavy weight, if you're not careful, you could rip the muscle off the bone. It happens to some bodybuilders or heavy weightlifters. But hopefully that won't happen to you because you have a fixator. Some of your muscles have another muscle that will help to hold the agonist in place as you're doing the motion, to help to hold or fix. To fix means to hold it in place. That's the job of the fixator. So those are different roles muscles could play. Make sure you know the definitions. One more time. An agonist or prime mover or primary mover does the desired action. The antagonist does the opposite of the desired action. The synergist removes unnecessary movements to help the agonist. And the fixator will hold or fix the agonist in place. So make sure you know those roles of different muscles. So from here on out, we're going to begin to explore different muscles in your body. Like usual, they're going to have some weird names, but like I always tell you, never be intimidated by names. Their names are always here to help. And like usual, their names are giving you hints. For a lot of these names, they can literally tell you where to find the muscle in the name. Or maybe the name is telling you if that muscle is big or small, or long or short. Sometimes if a muscle is long, it will have the word longus in the name. Or if it's short, it will have the word brevis in the name, because brevis means short. Or maybe it's telling you where it attaches. For example, you'll see there's a muscle called your sternocleidomastoid. It's really telling you its insertion and origin points. It's called sternal because part of it attaches to the sternum. Cleido or clido for clavicle because it also partly attaches to the clavicle. And it ends with the word mastoid because it attaches also partly to your mastoid process. So its name literally told you exactly where to find it because it was telling you where that muscle was attaching. So like usual, as we go through these muscles, we're not going to go through all of them. We'll pick out as much as possible. But we're going to kind of look at them. Their names will give you hints as to what it's doing or where you could find it. And in this chart on table 11.2, it's giving you these name breakdowns like I always usually do. I try to break down names for you to help it make more sense. Well, this table 11.2 is helping to do the same thing. It's just breaking down the names to show you their meaning, to help you to either locate it or learn something about that muscle. And like always, stick to the exam review. Right now, we're just going to go through some of the muscles in the body, kind of point them out to you, and then talk about what these muscles do. You're going to have to know the function of several muscles listed in your exam review. I'm going to go through several as I'm going through this lecture, but just make sure you stick to the exam review. And I'm just going to start from the top of the body, and we're going to work our way down. And we're going to start in the head and in the face. Turns out in the head and the face, you have several different muscles, each doing a different specific function to help you to move or express yourself in some type of manner. And so we could look at this picture here of a person's face in the cartoon. And you can see over the forehead is a small muscle. It's called the occipitofrontalis muscle, sometimes called the epicranius muscle. This muscle partly Lots of these muscles have lots of functions. I'm just going to mention one. And when I'm mentioning the functions, I'm going to give you the anatomical definitions, which might seem kind of strange when we talk about it, but it'll make sense as we go through it. So back to this occipitofrontalis. This muscle, as one of its functions, can elevate the eyebrows. Oh, what does it mean to elevate the eyebrows? It's when you raise your eyebrows and give someone that creepy, hey, what's up? You're using your occipitofrontalis muscle. It can help to elevate the eyebrows.